Okay, in the last class, we have discussed about RL transient circuit. We will do some problem on the RL transient circuit, so not transient, RL series circuit. So we have derived the formulas. In DC, what is the current formula? In DC, what is the current formula? I is equal to V by R. In AC, what is the current formula I?
I am into sin omega t plus.
In AC, current formula is I is equal to V by Z. In DC, what is the current formula? V by R. Because in DC we are having only resistance, but in AC we are having the R, L, and C. Any RL or RC, anything will be there. That's why we'll take the impedance Z. Z is called the impedance. Now we'll do one problem. Okay, right on. A choke coil takes a current of 2 ampere, 2 ampere, lagging 60 degrees, lagging 60 degrees behind the applied voltage of behind the applied voltage behind the applied voltage behind the applied voltage of 200 volts behind the applied voltage of 200 volts at 50 hertz of 200 volts at 50 hertz at 50 hertz. Calculate the calculate the inductance, comma, resistance. Calculate the inductance, comma, resistance and impedance of the coil and impedance of the coil and impedance of the coil. Also determine the power consumed. Also determine the power consumed. Also determine the power consumed. Okay, read the problem. Now see here, choke coil. This choke coil consists not only inductance L, but also some resistance is added inside the inductance. It is not only inductance, but some resistance is included in the inductance. It is the choke coil. Okay. Now in the problem, he is asking us to determine resistance, inductance, and impedance of this coil. Combination of R and XL is the impedance. Now, what is the voltage applying across this choke coil? What is the voltage applied across this choke coil?
200 volts. 200.
200 volts. Voltage 200 volts. Supply frequency is 50 hertz. The AC supply frequency is 50 hertz. He is applying. What is the current flowing in this choke coil?
2 ampere.
2 ampere. First, you have to draw the circuit in the exam so that you can understand what is given in the problem. Okay. In inductive circuit, current lags or leads voltage?
Lags.
Okay. Current is lagging the voltage. Current lags voltage by 60 degrees. In problem, he is saying that current is lagging the voltage by 60 degrees. That means your phi is 60. Your phi is 60 degrees. Now I have to calculate the resistance inductance. Before that, first I will write Z is equal to R plus J XL. R is taken on the x-axis, XL and Z. Phi is equal to 60. If you draw the right angle triangle, then you can determine easily. Draw this. R is the internal resistance of the coil. Small r is the internal resistance of the coil. R is the internal resistance of the coil. Okay. First one, what you will determine? See here, in the circuit, whatever the voltage and current they are giving, these are RMS values. Write a note. Suppose in the problem, if they are not specifying anything, peak value, instantaneous value, RMS value, we'll take it as RMS values. So in the problem, they are write a note. V and I are the RMS values given in the problem. V and I are the RMS values given in the problem. Remember this point. If they are not specifying anything, whether it is instantaneous or peak or RMS, generally they will give RMS values only in the problem. Please remember, these are the RMS values. First, I will calculate the Z value. Z is equal to V by I. First, calculate Z value. Verify the answers R value and XL value. Had everybody purchased the calculators, scientific calculators?
Yes, sir.
Okay. Because from next class onwards, it is very much essential in AC, because to convert the rectangle form to polar form and polar form to rectangle form, and how to calculate the complex numbers. From next class onwards, calculator should be must and necessary. Okay, it should be kept along with you during the class. Okay, in the problem he is asking R and L, but we have got R and XL. Now we have to calculate L value. How will you calculate L value?
XL equals to omega.
XL is omega L. What is omega?
50.
Okay. Omega is not 50. Frequency F is 50. So omega is 2 pi F. Substitute F is equal to 50. We will get L value. In the problem he is giving frequency is 50. Are you getting L value 0.275?
Yes, sir.
Okay. So XL unit is ohms, L unit is Henry. Unit of inductance is Henry. So this type of simple problems they will ask for 5 marks in exam. Okay, next problem. Take the problem. An inductive circuit, madam. An inductive circuit. An inductive circuit draws 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 DRAWS, draws 10 ampere and 1 kilowatt from a 200 volt from a 200 volt 50 hertz AC supply. Determine first bit. The impedance in the impedance in Cartesian form A plus JB. Second bit. The impedance in polar form Z at an angle theta. Next, third one. Power factor. Fourth one. Reactive power. Fifth one. Apparent power.
Sir, can you repeat questions again?
Question again.
Yes, sir.
An inductive circuit draws 10 ampere and 1 kilowatt from a 200 volt 50 hertz AC supply. Determine impedance in first bit. Impedance in Cartesian form A plus JB. Second bit, impedance in polar form Z at an angle theta. Third one, power factor. Fourth one, reactive power. Fifth one, apparent power. Is it okay?
Yes, sir.
Okay. See here, it is an inductive circuit. Inductive circuit means what is the unit of P? Watts. S is equal to P plus JQ. Unit of S is volt ampere. Unit of P is watts. Unit of Q is volt amp reactive, VAR. These are the units. In the problem, what he is giving? 1 kilowatt. 1 kilowatt means that is P. 1 kilowatt means P is 1000 watts. P is 1000 watts. This is the data given in the problem. So based on the data, I had drawn the diagram. Now I had to determine Z value in Cartesian form and also in polar form. First I determine in Cartesian. Cartesian form is also called as rectangle form. Rectangle form means A plus JB. A is the real part, B is the imaginary part. See here. First P is equal to I square R. I is 10. So from the formula I have determined R value. Now I know the R value. Because the formula for P is I square R. What is the formula for S? I square Z. Formula for P is I square R. Formula for Q is I square XL. Is it okay? We have derived this in the formula system. S is equal to I square Z.
Yes,
Or
sir.
VI. VI. This is VI cos phi. This is VI sin phi. We can take any formula. I square Z or VI. I square R or VI cos phi. Both are one and same. I square XL. So in the previous problem, have you determined P? See previous problem. In previous problem, have you completed the problem?
No, sir.
No, sir. No.
We have not completed. See what we have not determined in the previous problem.
Also determine power.
Form
Power
factor.
we have not determined. Okay, power we have not determined in the previous problem. Can you determine now? Previous problem, see. See, in the previous problem, he is just saying power. What is that power? Suppose in the problem, if he is not saying anything, power consumed is equal to active power, P. Real power or active power or true power. Remember one point. Power consumed means it is the active power. Active power or real power or true power. Okay. P is the. In the previous problem, we had to determine P. So use any formula. I square R or VI cos phi. In the previous problem, what is I?
2,
What is R? We have determined
50.
50. Or V is 200. I is 2 cos 60. We can use any formula. Now calculate and see how much you will get.
200.
200. Watts. So that is the previous problem we have forget to calculate. And one more thing, while calculating the powers, we have to take RMS values only. Okay, I and V are RMS.
2000.
200 in there. 200 see properly. 4 into 50 is 200.
Yes.
Okay. So that is our previous problem. Now come to our problem, this problem, current problem. Now see the current problem. Read the problem. What he is asking in the current problem.
Impedance in polar form.
Okay, first one is impedance in polar form.
Cartesian form, sir. It's like this.
Cartesian form or rectangle form. Z is equal to R plus JXL. A plus JB. Your A is R here. B is XL. R is A. B is XL. Now I know R value. Can I determine Z value here? What is the formula for Z?
V by
V by I. V is 200. I is 10. How much?
20.
20 ohms. Now I know R and Z. See here. From this I will get XL value and Z value. From this I will get the XL value. How much?
300.
17.32.
Take the square root. After taking the square, XL square that is. If you bring square to this side, it will become square root. Square root of that is 17.32 ohms. Unit of XL is ohms. Now we can write in Cartesian form. That is Z is equal to R is 10, XL is 17.32. This is the first bit, Cartesian form. Now take your calculator, convert it into polar form. Second bit is polar form. In your calculator, POL is there. Go for POL. First write the real part, comma, imaginary part, 10, comma 17.32. Take your calculator and in calculator, take POL. Is there in your calculator? See. Is it there? POL is there in calculator?
No, sir.
You take shift POL. Press shift and POL.
Yes, sir.
Okay. You press shift POL. You will get that. POL 10, comma 17.32. What you are getting? Are you getting this?
Sir, how 10 comma?
10 is real part. See, 10 is the real part. Comma, what is imaginary part? 17.32.
Yes, sir.
So in your calculator, you have to take like this. If you want to convert to polar form, take in your calculator POL 10 comma 17.32. Then you will get magnitude is 20, Z is 20, angle is 60. Press enter. After POL bracket 10 comma 17.32, press enter. Is equal to. Press is equal to. Press చేశారు. Are you not getting this? You will get R and theta. R is Z here. వస్తుందా? Are you getting?
No, sir.
So in your calculator, are you getting POL?
Yes, sir. POL bracket, that comma, like,
Comma is there in your calculator, you see. Beside AC. I think beside AC it is there, I think, you see. Shift comma, shift press, shift and that one, comma. Shift, press shift and comma, I think. Otherwise, comma only. Without shift also, I think. I don't know exactly. Are you, the comma is there?
yes, sir.
Okay. 10 comma 17.32.
Yes, sir. R equal to 19.99. Theta
Okay,
equals
right.
to 9.
Theta is equal to 60.
59 it's given.
Okay, 59 means approximately 60. In your textbook, they are giving 60. 20. 19.99 means it is 20. Magnitude is 20. Angle is 60. Okay. This is Z at an angle theta. This is in polar form. So now we have converted it into polar form. Z at an angle theta. Suppose if you want to convert it into manually without calculator, see how you will do. See the magnitude. Square root of a square plus b square. Magnitude is square root of a square plus b square. Here a is r, xl is b. Square root of real part square plus imaginary part square. What is tan phi? Imaginary part by real part. If you do this, we will get same thing. Z value will get 20, phi value will get 60. Otherwise, we can draw the right angle triangle. One more method is there. Already right angle triangle is there. See, what is tan phi from this? From this triangle, what is tan phi?
XL by R.
XL by R. What is the imaginary XL? 1 minute. XL by R. You know XL, 17.32. Divided by R is 10. Take tan inverse that value. Phi is equal to tan inverse of that one. Phi is equal to tan inverse of that one. You will get 60. Okay.
Yes.
Getting?
Yes, sir.
60 you will get. If you take tan inverse of this, phi is equal to tan inverse of this. This will be 20. So if you are not using the calculator, POL, you have to calculate like this manually.
Sir, J square value 1 now, sir.
Which one?
J square.
We are not taking J square here. See right angle triangle. What is the impedance? Z square is equal to hypotenuse square is equal to side square plus side square. Z is equal to square root of r square plus xl square. From right angle triangle, is it okay?
Yes, sir.
Hypotenuse square is equal to side square plus side square. If you bring square to this side, it will become square root of r square plus xl square. That is the magnitude. But we want angle also in polar form. Angle will get tan phi is equal to imaginary part by real part. Your imaginary part is xl, real part is r. Otherwise, opposite side by adjacent side. Tan phi is equal to opposite side by adjacent side. xl by r. Take inverse, tan inverse of that one. You will get 60 degrees. It is better to use the calculator. It will be very simple instead of going all for all these things. Okay. Next, that is for A bit and B bit. Now come to the C bit.
Power factor.
Now your third bit is power factor. What is power factor formula?
Cos phi.
Cos phi. What is phi?
60.
60. In brackets, we have to write lagging. You will get 0.5 because in inductive circuit, current lags the voltage. Your power factor will be lagging. In inductive circuit, current lags the voltage. So power factor will be lagging. Next, fourth bit.
Apparent power.
Fourth bit is reactive power, I think. See.
Yes.
Q is the reactive power. Formula for Q is I square XL or VA cos phi. VA sin phi. What is V? I
200.
is okay 200. I is 10 sin 60. Because we can use this formula or I square XL. I square is 10 square. What is XL?
17.3.
17.32. Now verify the answer.
One seven three two.
Okay, 1732. Use any formula. I square XL or VI sin phi. We can use any formula. Now you have calculated Q. Suppose if you want to calculate from the triangle, right angle triangle, how will you calculate?
Hypotenuse square equals side square plus x.
Okay. Q is equal to same thing. Q is equal to sin phi is equal to S by Q.
Same we will get. Sorry, Q by S. Sin phi is equal to Q by S. Q is equal to S into sin phi. But S is VI. Same formula we have calculated. Okay. Sin phi is equal to Q by S. Q is equal to S into sin phi. Formula for S is VI. Okay. Now in the problem we have calculated Q. Now what we have to calculate?
P.
Yes. Apparent power. S is equal to VI. Formula for S is VI or I square Z. Calculate and tell me the value. S value.
Two thousand.
Unit for S is VA, volt ampere. We can use any formula. S is equal to VI or I square Z. So that's all about the problem. Take the next problem. A 120 volt a 120 volt 60 watts lamp 60 watts lamp is to be operated on is to be operated is to be operated is to be operated on is to be operated on 220 volt 50 hertz supply mains. 220 volt 50 hertz supply mains. Calculate what value of what value of what value of what value of first bit non-inductive resistance. First bit non-inductive resistance. First bit non-inductive resistance. Second bit B. Second bit B. Pure inductance pure inductance. Pure inductance would be required would be required in order that in order that in order that in order that lamp is run 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 lamp is run on correct voltage. Lamp is run on correct voltage. Lamp is run on correct voltage. Okay, read the problem. So he is taking the lamp. What is the rating of the lamp?
$60.
Lamp voltage is 120 volts. The lamp is operating at 120 volts, 60 watts. And this is connected across
220 voltage.
Okay. And this lamp is connected across AC voltage of 220 volts,
50 hertz.
50 hertz. Frequency of this AC source is 50. In the first case, what he is doing? What is the first one? First case?
Non-inductive.
Okay. Non-inductive resistance means pure resistance. Remember, if you want to note, you can note. Non-inductive resistance means it is the pure resistance. Non-inductive resistance means pure resistance. Now in the second case, he is connecting pure inductance. In the second case, he is connecting pure inductance. Now he is asking to calculate R value in the first case, L value in the second case. So how much in the first case, how much resistance we have to connect in series with the lamp so that the bulb will glow brightly. So we have to determine this R value in the first case. In the second case, he is asking how much value of inductance we have to connect in series with the bulb, 60 watts bulb, so that the bulb will glow brightly. If you add how much resistance R value in the first case, the bulb will glow brightly. In the second case, how much inductance if you add in series with the bulb, so that the bulb will glow brightly. We have to determine R in the first case, L in the second case. Okay. Now we'll determine. What is the bulb? Is it the resistive filament? What is bulb? Inside bulb, what is there? Resistance filament is there. Bulb is the resistive filament. Remember this. Bulb is the resistive filament. Is it okay? Write a note. Bulb is the resistive filament. Write a note. Bulb is the resistive filament. Bulb is the resistive filament. So voltage across the bulb is VB. Voltage across R is VR. Voltage across the bulb is VB. Voltage across the resistance is VR. Voltage across the inductance is VL. So in series, resistances can be added. Series resistances can be added. See here. See the difference for the first one and second one. Is it okay?
And
Any doubt in this one? Equation 1 and 2.
oh, sir.
Okay. In the first case, both are resistances. Only real part is there. In the first case, both are resistances. VB and VR both are resistances. There is no imaginary part there in the first case. In the second case, inductance is the imaginary part. Your real part is resistance, VB. In the second case, VB is the resistance, real part. Imaginary part is VL. Inductance is plus J XL. XL means here multiply with current, we will get VL. Okay, that is the difference between the first case and second case. In the first case, what is VR?
100.
VR is 100. In the second case, hypotenuse square is equal to side square plus side square. Hypotenuse square is equal to side square plus side square. This is VB. This is VL. This is V. V is 220. V is 220 volts. And VB is 100. 120, sorry. VB is 120. 120 volts. So V is 220 square. VB is 120 square. That is VL square. From this we will get VL. That is your VL. So in the first case, you see, this is VB, this is VR. Therefore, V is equal to VB plus VR. In the first case, there is only real part. In the first case, there is only real part. VB and VR are both are real part. There is no imaginary part. But in the second case, there is imaginary part. What is VL?
One 4.391.
Okay. 184.4. In your textbook, they have given 184.4 volts. Now, what he is asking in the problem?
Non-inductive.
Non-inductive.
Non-inductive resistance, R value. In the first case, R value. In the second case, L value. Now see here. Current in these two are same. VR is equal to I into R. VL is equal to I into XL. In series, current will be same. Whatever the current flowing in the bulb, the same current will flow in resistance also. Whatever the current flowing in the bulb, same current will flow in the resistance. Similarly, in the second case, whatever the current flowing in the bulb, same current will flow in inductance also. Therefore, I is same in bulb and resistance. How will calculate I value? If you know I value, I can get R and XL. If I know the I value. So now let us take here power P is power in the bulb. What is the power in the bulb? 60
The
watts.
screen is blurred, sir.
1 minute. I will 1 second. So I will tell right down that PB, power in the bulb. PB is equal to VB into I. PB is equal to VB into I. What is PB? Power in the bulb. I don't know why it is getting blurring. Nothing is visible.
Now visible, sir. Now visible.
Okay. See here. Power in the bulb PB. See the diagram. Power in the bulb. How much? What is the power of the bulb they have given?
60 watts.
60 watts. What is the voltage in the bulb?
120.
110
120.
volts.
120.
Okay. Formula for power in the bulb, see I have written PV is equal to VB into I. VB into I. From this I will get the current in the bulb. Current in the bulb is 0.5 ampere. Now what is the current flowing in the resistance? Current in the bulb is 0.5. What is the current in the resistance?
0.5.
0.5. Because in
Six.
series current will be same. Whatever the current flowing in this bulb, same current will flow in R also. Now I got I value. Now substitute this I value here. Substitute the value in the above equation here. We'll get R value. R is
200.
200 ohms. Similarly, in the second case also, same. I is 0.5 ampere. Same current will flow in L also. Same current will flow. Whatever the current flowing 0.5 here, same current will flow here also. Same current will flow there also. I is 0.5 in the second case also. I think screen is struck.
Yes, sir.
Yes.
Again,
Screen
blurred.
struck in the
Yes, sir. Blur.
1 minute. 1 minute it will come. One second. One minute, it is not coming. Okay, anyway, have you got the point?
Yes, sir.
I value is same in both the cases. 0.5 ampere. Now substitute here. I in place of I substitute I, will get XL. XL how much will get?
Three sixty
How much? 3?
68.80.
369 points.
Okay. Whatever you get, substitute frequency value, F value, will get L value. So that is the L value, 1.17 Henry. Okay, I will stop here. That is the L value. So if you connect this much of inductance in series with the bulb will glow brightly. Conclusion is, if R is equal to 200 ohms, the bulb will glow brightly. That much resistance you have to connect in series with the bulb to glow brightly. In the second case, if you connect 1.17 Henry inductance in series with the bulb will glow brightly. Okay, I'm stopping the class here. I will take attendance. Wait for some time.